The morning of August 15th, 1943, over the Straits of Messina, Hauptmann Klaus Weber banked his Messerschmitt Bf 109 hard left, tracking what he assumed was another American P-40 Warhawk climbing out of a strafing run on German coastal positions. The twin-boomed silhouette had become familiar over Sicily Americans flying close support missions, harassing ground troops, nothing particularly threatening to an experienced fighter pilot. Weber had 16 confirmed kills. He knew how to handle Allied fighter bombers. Then the American aircraft dropped something. Not the single bomb Weber expected from a fighter on a nuisance raid. Not even 2 bombs. He watched, incredulous, as 4 dark objects separated from the twin-boomed fighter, 2 from under the center fuselage, 2 more from under the wings. Each object fell in a ballistic arc toward the German supply column, moving along the coastal road below. Cracks of small fragmentation bombs. They were the deep, thunderous detonations of 500-pound general-purpose bombs, 4 of them. From a single aircraft he had dismissed as a light fighter. Weber's wingman, Lieutenant Hans Dietrich, broke radio silence. His voice carried confusion more than alarm. "Herr Hauptmann, that was not a fighter. What kind of aircraft carries such ordnance?" Weber didn't answer immediately. He was calculating, trying to reconcile what he'd just witnessed with everything he knew about American tactical aviation. A Stuka, the Luftwaffe's own Junkers Ju-87 dive bomber, carried 1,000 kilograms at maximum load, roughly 2,000 pounds. This American fighter, this twin-boomed machine he'd been ignoring as a minor threat, had just delivered twice that weight in a single pass. And unlike a Stuka, vulnerable and slow, this aircraft was now accelerating away at speeds Weber's Messerschmitt would struggle to match in level flight. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The American formation, there were 6 of them, Weber could see now was not finished. They came around in a wide arc, repositioning for another attack, but they weren't lumbering like bombers. They moved with the speed and agility of fighters, maintaining formation, coordinating their approach with a precision that suggested extensive training in this exact mission profile. Weber had encountered American bombers before B-17 Flying Fortresses, B-24 Liberators, massed formations defended by clouds of escort fighters. Those were strategic assets, high-altitude precision bombers that required entire fighter groups to protect them. This was different. These aircraft needed no protection. They were the fighters and the bombers simultaneously. The second wave of bombs fell on the German positions. More 500-pounders, walking across the roadway in a pattern that suggested the American pilots could see exactly what they were hitting. Supply trucks exploded. Ammunition carriers detonated in secondary blasts that threw debris hundreds of feet into the air. Weber watched German soldiers scatter into the rocky terrain along the coast, abandoning their vehicles, seeking any cover from the aerial assault. The psychological impact was immediate and profound. His own ground forces, veterans of the Eastern Front and North Africa, men who had endured Soviet artillery barrages and British armor attacks, were running from 6 American aircraft. Weber had been briefed on American capabilities. Intelligence reports described the P-38 Lightning, that was the designation, he remembered now as a long-range escort fighter, useful for protecting bomber formations, but not particularly dangerous in air-to-air combat below 20,000 feet. Heavy, the reports said. Twin engines made it less maneuverable than single-engine fighters. A specialized aircraft, limited in its tactical applications. Nothing in those intelligence assessments had mentioned this. Nothing had prepared him for the sight of a fighter carrying the bomb load of 2 Stukas while maintaining the speed to evade interception. To understand why Weber and his fellow Luftwaffe pilots found this capability so shocking, you must understand how the German military conceived of tactical air power in 1943. The Luftwaffe had built its entire operational doctrine around specialized aircraft, each designed for a specific, limited role. This specialization was not an accident of engineering. It was deliberate military philosophy, rooted in German experiences from the First World War and refined through the Spanish Civil War and the early campaigns in Poland and France. The Junkers Ju-87 Stuka represented the pinnacle of this specialized thinking. Designed in the mid-1930s, the Stuka was purpose-built for one mission: precision dive bombing in support of ground forces. It carried a maximum bomb load of 1,800 kilograms, approximately 4,000 pounds, when configured for short-range missions with minimal fuel. But this was theoretical maximum, rarely achieved in combat operations. Standard combat load was one 500-kilogram bomb mounted under the fuselage centerline, plus 4 50-kilogram bombs under the wings. Total, 900 kilograms, roughly 2,000 pounds. This was the load that allowed the Stuka to maintain adequate fuel for combat operations, achieve the altitude necessary for effective dive bombing, and retain some defensive capability. The Stuka's design prioritized accuracy over all other considerations. Its inverted gull wings provided excellent pilot visibility downward. Its fixed landing gear, while creating aerodynamic drag, served as dive brakes when fitted with special spoilers. The aircraft could enter near vertical dives, achieving the precision necessary to hit small targets like bridges, artillery positions, and individual tanks. German pilots trained extensively in dive bombing technique, learning to hold their dives until below 1,000 meters before releasing ordnance. This precision made the Stuka devastatingly effective in the early war years, when Luftwaffe fighters controlled the skies and enemy fighter opposition was disorganized or absent. But this specialization came with severe limitations. The Ju-87B variant, the most common version in service during 1943, had a maximum speed of 380 km per hour, roughly 235 miles per hour. Cruising speed was even slower, around 250 km per hour. The aircraft was painfully vulnerable to fighter attack. Its fixed landing gear created drag that prevented evasive maneuvering. Its defensive armament consisted of two forward-firing 7.92mm machine guns and a single rear-facing machine gun operated by the radio operator. Against a determined fighter attack, these weapons were nearly useless. German tactical doctrine accepted these vulnerabilities because the Stuka was never intended to operate without fighter escort. The operational model was clear. Messerschmitt Bf 109 and Focke-Wulf FW 190 fighters would establish local air superiority over the target area. Once enemy fighters were swept from the sky, Stuka formations would approach, conduct their precision attacks, and withdraw under continued fighter protection. This system had worked brilliantly in Poland in 1939, in France in 1940, in the Balkans in 1941, and during the early phases of Operation Barbarossa in Russia. By 1943, however, this doctrine was failing. Allied fighters were too numerous, too well coordinated, and increasingly too capable. Stuka losses had become unsustainable wherever Allied air forces achieved even temporary local superiority. The Battle of Britain in 1940 had demonstrated the Stuka's vulnerability. Attacks on Britain in August of that year resulted in catastrophic losses, entire Stuka formations decimated by Royal Air Force Hurricane and Spitfire fighters. The Luftwaffe withdrew the Ju-87 from operations over Britain after less than 3 weeks of combat. The Americans approached tactical air power from an entirely different philosophical foundation. Rather than specialized aircraft for narrow roles, American designers and military planners increasingly favored multi-role capability. This was partly pragmatic. American industrial capacity could produce aircraft in quantities that made some redundancy acceptable, but it was also doctrinal. American military thinking emphasized flexibility and the ability to rapidly shift resources to exploit opportunities or respond to threats. The Lockheed P-38 Lightning emerged from this thinking, though not initially as a fighter-bomber. In 1937, the United States Army Air Corps issued a specification for a high-altitude interceptor capable of reaching 20,000 feet in 6 minutes and achieving speeds exceeding 360 miles per hour at that altitude. The specification was ambitious, perhaps overly so. No single-engine fighter design could meet these requirements with existing engine technology. Lockheed's design team, led by Hall Hibbard and his chief engineer Clarence Kelly Johnson, proposed a radical solution: twin engines, twin booms, and a central nacelle for the pilot and armament. The prototype, designated XP-38, first flew in January 1939. It was unlike any fighter in service with any air force in the world. 2 Allison V-1710 liquid-cooled engines, each producing more than 1,000 horsepower, mounted in booms extending back from the wing. The pilot sat in a central nacelle between the booms, giving him unobstructed forward visibility and eliminating the engine noise and vibration that complicated other fighter designs. The armament was concentrated in the nose: 4 50-caliber Browning machine guns and 1 Hispano 37mm cannon, all firing forward along the aircraft's centerline, with no need for convergence adjustment. The configuration had significant advantages. Twin engines provided redundancy. The aircraft could return to base on a single engine if necessary. The counter-rotating propellers eliminated torque effects that complicated takeoff and landing in single-engine fighters. The tricycle landing gear, another innovation for American fighters, made ground handling safer and easier. The concentrated nose armament meant devastating firepower on target without the ballistic complications of wing-mounted guns, but the P-38 was heavy. Early production models weighed over 14,000 pounds empty, approaching 18,000 pounds loaded with fuel and ammunition. This was nearly twice the weight of a Messerschmitt Bf-109. The twin-engine configuration created drag that affected maneuverability, particularly at lower altitudes where most fighter combat occurred. Early combat reports from Europe noted that Luftwaffe pilots could outturn the P-38 in sustained dogfights below 15,000 feet. What American commanders recognized, however, was that the P-38's weight and twin-engine power created an unexpected capability. The aircraft could carry external stores. The center section between the booms was reinforced during production, allowing the installation of a hardpoint capable of carrying a 1 to 1,000 or even 2,000-pound bomb. The wings could be fitted with pylons for additional 500-pound bombs or fuel tanks. By 1943, field modifications and factory upgrades had transformed the P-38 from a pure interceptor into a true multi-role aircraft capable of air superiority, long-range escort, ground attack, and even level bombing missions. The transformation of the P-38 Lightning from interceptor to fighter bomber happened not in Lockheed's design offices, but in the combat theaters themselves, driven by commanders who recognized that the aircraft's capabilities exceeded its original specifications. The first systematic use of the P-38 as a bomber occurred in the Pacific Theater during 1942, where 5th Air Force units in New Guinea experimented with mounting bombs on aircraft that had been delivered as pure fighters. The early attempts were crude. Ground crews fabricated makeshift bomb racks from available materials, welding steel frameworks to the hardpoints that had been designed for drop tanks. The first bombs carried were relatively small, 250 and 500-pound general-purpose bombs, because no one was certain how the aircraft would handle with heavier loads. Pilots reported that the P-38 remained controllable even with external ordnance, though the added weight and drag reduced top speed and climb rate. More importantly, the aircraft could deliver these bombs with reasonable accuracy and then fight its way home if intercepted. No other American fighter in the Pacific could do this. By early 1943, Lockheed had formalized these field modifications into production standards. The P-38G model and subsequent variants included reinforced center section hardpoints rated for loads up to 2,000 pounds. Wing pylons were standardized to carry either fuel tanks or bombs up to 500 pounds each. The aircraft could be configured in multiple ways depending on mission requirements, A single 2,000-pound bomb on the centerline for maximum destructive power against hardened targets. 2. 1,000-pound bombs on the centerline and wing, pylons for balanced load distribution, or 4 500-pound bombs, 2 on the centerline pylon in tandem, 2 more under the wings for the maximum number of individual targets that could be engaged. This last configuration, 4 500-pounders, gave the P-38 a total bomb load of 2,000 pounds, while maintaining sufficient fuel for combat radius missions of 300 to 400 miles. The aircraft retained its full armament of 4 50-caliber machine guns and 1 20mm cannon. Unlike dedicated bombers that were helpless if intercepted, the P-38 could fight before, during, and after its bombing run. Unlike the Stuka, which required fighter escort and couldn't defend itself effectively, the Lightning was its own escort. The 9th Air Force in the Mediterranean began receiving P-38s equipped for fighter-bomber missions in spring of 1943. The 1st and 14th Fighter Groups, both equipped with Lightnings, trained extensively in ground attack techniques while maintaining their primary air superiority mission. Pilots learned to approach targets at medium altitude, identify their aiming points, roll into shallow dives of 20 to 30 degrees, nothing like the Stuka's vertical plunge and release ordnance between 3,000 and 5,000 feet. The technique sacrificed the precision of true dive bombing, but maintained the speed and maneuverability necessary to evade anti-aircraft fire and engage enemy fighters. The critical advantage was psychological and tactical rather than purely technical. A formation of 6 P-38s could deliver 12,000 pounds of bombs, the equivalent of a dozen Stuka sorties, while remaining fully capable of air-to-air combat. They needed no escort fighters. They could loiter over the target area, making multiple passes if necessary. If enemy fighters appeared, the Lightnings could jettison their remaining bombs and engage immediately. German tactical doctrine had no effective counter to this capability, because it existed outside the framework of specialized roles that defined Luftwaffe thinking. German intelligence officers studying the P-38 recognized its long-range capability and noted its use as a bomber escort. Reports from North Africa and Sicily mentioned its ground attack missions, but these reports treated the bomber role as secondary, almost incidental. The prevailing assessment remained that the P-38 was primarily an escort fighter that could carry bombs when necessary, not a purpose-designed fighter bomber that threatened to make the entire concept of specialized attack aircraft obsolete. This misunderstanding was not stupidity. It was the product of institutional thinking so deeply rooted that evidence contradicting it was reinterpreted to fit existing frameworks rather than forcing a re-evaluation of those frameworks. By summer of 1943, American fighter-bomber doctrine had evolved to exploit the P-38's unique capabilities. Mission planning emphasized flexibility. A single squadron could be briefed for multiple contingencies. If enemy fighters appeared over the target, engage them first with full fighter capability. If no opposition materialized, conduct the planned bombing attack. If targets of opportunity appeared en route, individual flights could break off to engage, while the rest of the formation continued to the primary target. This adaptability was impossible with specialized aircraft like the Stuka, which could only execute its designed mission and had no capability to respond to changing tactical situations. The campaign for Sicily in July and August of 1943 forced the Luftwaffe to confront the P-38's fighter-bomber capability on a scale that could not be dismissed or rationalized. German forces defending Sicily faced constant pressure from Allied tactical air power, but the P-38 operations stood out for their persistence and effectiveness. Unlike heavy bomber raids that followed predictable patterns and required hours of preparation, lightning strikes appeared with little warning, hit with devastating accuracy, and disappeared before effective countermeasures could be organized. On August 10, 1943, 6 P-38s from the 1st Fighter Group's 71st Fighter Squadron attacked German positions near Randazzo on Sicily's northeastern coast. The mission profile was representative of dozens conducted during the Sicily campaign. The formation departed their base in Tunisia at 0830 hours, carrying a mixed load of bombs. Each aircraft had two 500-pound general-purpose bombs on the centerline pylon and two more 500-pounders under the wings. Total load per aircraft, 2,000 pounds. Total formation load, 12,000 pounds, equivalent to the maximum theoretical load of 6 Ju, 87 Stukas operating at their absolute capacity. The Lightnings climbed to 15,000 feet for the transit across the Mediterranean, maintaining formation while navigating by dead reckoning and radio compass. The flight time from Tunisia to Sicily was approximately 45 minutes. At this altitude and cruise speed, the external bomb load reduced the P-38's range by roughly 15% compared to a clean fighter configuration, but still allowed comfortable margins for combat operations over the target and the return flight. No other single-engine Allied fighter could match this combination of range and payload. The Republic P-47 Thunderbolt could carry bombs, but its combat radius was significantly shorter. The North American P-51 Mustang wouldn't enter service in numbers until later in the war. German radar stations on Sicily tracked the American formation as it approached from the south. The radar operators noted the altitude and at heading, classifying the contact as another fighter sweep a routine occurrence by this stage of the campaign. No special alert was issued. The standard defensive posture called for Luftwaffe fighters to scramble only if the formation appeared to be escorting bombers or if it descended to attack altitude. 6 aircraft at 15,000 feet, apparently heading for the Messina Straits, did not warrant immediate response. This was exactly the profile that P-38 missions exploited. They looked like fighters until they revealed themselves as bombers. The Lightning formation reached its initial point 5 miles south of Randazzo at 09:15 hours. The flight leader, Captain Richard Campbell, radioed his pilots with brief instructions. "Switch is hot. Watch for flak. Make your run and climb back to altitude." The formation rolled into their attack dives, descending from 15,000 feet to 5,000 feet in a shallow, 30-degree dive that built airspeed to over 400 miles per hour. Each pilot selected his target from the German supply convoy, moving along the coastal road trucks, half-tracks, artillery tractors, all crowded together because the narrow coastal road offered limited space for dispersal. The bombs fell in pairs, 2 aircraft attacking simultaneously from slightly offset angles to bracket the target area. 500-pound general-purpose bombs were not precision weapons, but they didn't need to be. Their blast radius against unarmored vehicles exceeded 100 feet. Near misses were often as effective as direct hits. The first pair of bombs detonated in the center of the convoy, directly among a cluster of supply trucks. The explosions threw vehicles into the air, flipped trucks onto their sides, and ignited fuel tanks that added their own secondary blasts to the carnage. The second pair hit slightly north, catching an ammunition carrier that detonated with such violence that fragments were later found over 300 yards from the impact point. German soldiers who survived the initial attack described the psychological effect as more devastating than the physical damage. They had experienced artillery barrages on the Eastern Front, Soviet Katyusha rocket attacks, even Allied heavy bomber raids from high altitude. But this was different. These aircraft appeared without warning, struck with precision, and were gone before the troops could process what had happened. The soldiers couldn't see the bombers approaching because the Lightnings had dived from high altitude at high speed. By the time they heard the aircraft engines screaming in the dive, the bombs were already falling, and unlike Stukas, which made distinctive screaming sounds due to their dive siren Jericho trumpets, the Lightnings attacked in relative silence, their bombs announcing their presence only in the final seconds before impact. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Lightning pilots pulled out of their dives between 4,000 and 5,000 feet, well within the effective range of German light anti-aircraft fire. but they were already accelerating away at speeds approaching 450 miles per hour. German 20mm and 37mm flak opened fire, filling the sky with exploding shells. But the Lightnings were too fast and too maneuverable. They climbed back to altitude in a wide arc, reforming their formation while assessing damage to the target. Within 3 minutes of their initial attack, they were back at 12,000 feet, beyond effective range of ground fire, ready to engage any German fighters that might respond. Hauptmann Weber and his wingman, who had been conducting a routine patrol over the straits when the attack occurred, arrived over Randazzo 7 minutes after the American aircraft departed. Weber could see the smoke from ground fires rising to several thousand feet. The coastal road was chaos, burning vehicles, scattered equipment, soldiers attempting to organize rescue efforts for wounded comrades. His radio crackled with reports from ground controllers. Multiple aircraft, heavy bombs, fast attack, no warning. The Americans were gone before fighters could intercept. Weber descended to investigate, circling the damaged convoy at 3,000 feet while maintaining sufficient altitude and speed to evade ground fire from nervous German anti-aircraft crews. What he observed confirmed his growing concerns about American tactical air capabilities. The damage pattern showed multiple impact points spread along several hundred yards of roadway. This wasn't random bombing from high altitude. This was precise, deliberate targeting by pilots who could see exactly what they were hitting. The fact that the attacking aircraft had escaped without loss suggested they possessed both the speed to avoid interception and the situational awareness to detect defending fighters before engagement. The intelligence reports Weber had received about the P-38 emphasized its weaknesses in close combat. The reports noted its poor rate of roll at high speeds due to control system design issues. They mentioned its tendency to suffer compressibility problems in high-speed dives, where control surfaces became ineffective and the aircraft could enter dangerous flight regimes. These were real limitations, documented by Luftwaffe pilots who had engaged Lightnings in air combat. But none of these weaknesses mattered if the P-38 never entered close combat. If it could strike ground targets and escape before interception, its dogfighting limitations were irrelevant. Weber filed his after-action report that evening. He noted the bomb load, the attack profile, the lack of escort fighters, and the impossibility of effective interception given the speed and altitude advantage that Americans maintained. His report was forwarded through channels to higher headquarters, where it joined dozens of similar reports from other Luftwaffe units across Sicily and southern Italy. Staff officers read these reports. They noted the patterns. But changing doctrine required more than acknowledging problems. It required admitting that fundamental assumptions about air power were wrong. The Luftwaffe's institutional response to the P-38 fighter bomber threat revealed how deeply entrenched specialized thinking had become. Rather than reconsidering the doctrine of specialized aircraft, German planners focused on tactical countermeasures. They recommended earlier scrambles of defending fighters, better coordination between radar stations and fighter units, and more aggressive patrols over vulnerable ground forces. These were reasonable tactical responses, but they didn't address the strategic problem. The Americans had fielded an aircraft that could perform multiple roles simultaneously, invalidating the entire concept of specialized attack aircraft requiring dedicated escort. German aircraft designers had produced their own twin-engine fighters, the Messerschmitt Bf 1-10 and the later Me 4-10, but these were conceived primarily as bomber-destroyers and night fighters, not multi-role fighter bombers. The Focke-Wulf 4-190, entering service as a single-engine fighter bomber, could carry up to 1,000 pounds of bombs, but its combat radius with this load was severely limited compared to the P-38. No German aircraft in production or development matched the Lightning's combination of range, payload, speed, and air-to-air capability. The industrial capacity to develop such an aircraft existed in Germany, but the institutional framework to recognize its necessity did not. Luftwaffe procurement priorities in 1943 emphasized defensive fighters for homeland defense against Allied bombing raids and specialized ground attack aircraft for the Eastern Front. Multi-role capability was considered a compromise that produced mediocre performance in all roles rather than excellence in one. This thinking was not illogical given German strategic circumstances. With resources limited and production capacity strained, specialization seemed more efficient than developing complex multi-role aircraft. But efficiency in production meant vulnerability in combat. The Stuka remained in service on the Eastern Front because Soviet fighter opposition was less effective than in the West, and the aircraft's precision remained valuable for anti-tank operations. But in Sicily, Italy, and soon in France, the Stuka was effectively extinct as a viable combat aircraft. It could not survive in contested airspace against Allied fighters. And increasingly, it couldn't even reach the battlefield because Allied fighters like the P-38 could interdict ground forces without requiring specialized attack aircraft that needed protection. The lessons learned over Sicily in summer of 1943 became doctrine by autumn. American tactical air forces refined their fighter-bomber operations, standardizing mission profiles that exploited the P-38's capabilities while minimizing exposure to German defenses. The 12th Air Force, operating from Italian bases after the invasion of the mainland in September, routinely dispatched Lightning formations on armed reconnaissance missions, sweeps over German-held territory, with authority to attack any target of opportunity encountered. These missions carried standard loads of 4 500-pound bombs, plus full air-to-air armament. The psychological impact on German ground forces was cumulative and debilitating. Soldiers moving supplies, reinforcing positions, or simply trying to reposition units lived in constant fear of attack from aircraft that appeared without warning. Unlike heavy bomber raids that could be predicted based on weather and time of day, fighter-bomber strikes occurred throughout daylight hours, whenever visibility permitted. The Lightnings operated in small formations, typically 4 to 8 aircraft that were difficult to track on radar and could attack from multiple directions simultaneously. German anti-aircraft defences, already strained by the volume of Allied air operations, proved largely ineffective against fast-moving targets that spent only seconds in weapons range. German commanders adapted by moving more operations to darkness, dispersing forces more widely, and camouflaging critical installations with greater care. These were sensible countermeasures, but they extracted costs in operational efficiency. Moving at night slowed logistics by 50% or more on the winding Italian roads. Wider dispersal required more fuel for transport and reduced the concentration of combat power available for counterattacks. Improved camouflage required labor and materials that were increasingly scarce. The P-38's fighter-bomber capability didn't just destroy German equipment. It forced changes in behavior that degraded overall military effectiveness even when attacks missed their targets. The Luftwaffe's response evolved as well, though constrained by resources and strategic imperatives. Fighter units defending Italy received orders to prioritize interception of fighter bombers, but executing these orders proved difficult. The P-38s operated at altitudes where German fighters had no performance advantage. The Bf-109 and Fw-190 could outturn the Lightning in sustained dogfights, but catching it before bombs were dropped required perfect positioning and favorable tactical circumstances. More often, German fighters arrived too late, finding only smoke from burning targets, and American aircraft already climbing back to altitude beyond effective interception range. German pilots who did engage P-38s loaded with bombs discovered another unwelcome reality. The Americans simply jettisoned their ordnance and fought. Unlike Stuka pilots, who were helpless if caught by fighters, Lightning pilots could drop their external stores in seconds, instantly converting from bomber to fighter configuration. The weight reduction and drag elimination gave the P-38 performance nearly equal to its clean configuration. German pilots found themselves in even fights against opponents who moments before had been carrying 2,000 pounds of bombs. The tactical flexibility was unprecedented in their experience. By late 1943, Luftwaffe intelligence had compiled comprehensive assessments of P-38 capabilities, including detailed analyses of its fighter-bomber operations. These reports circulated through command channels, reaching fighter group commanders and tactical planning staffs. The assessments were technically accurate, documenting bomb loads, attack profiles, and operational patterns. But accurate intelligence could not overcome material disadvantages. German forces knew what they faced. They understood the P-38's capabilities. They simply lacked the resources, aircraft numbers, fuel supplies, pilot training time to counter it effectively. The industrial dimension of this disparity became increasingly apparent as the war continued. Lockheed produced over 10,000 P-38 Lightnings during the war, with production peaking at approximately 400 aircraft per month during 1944. These numbers represented only one of several American fighter types in mass production. Republic built over 15,000 P-47 Thunderbolts. North American manufactured more than 15,000 P-51 Mustangs. The combined output of American fighter-bomber-capable aircraft exceeded German production of all aircraft types by substantial margins. Quality mattered in combat, but quantity had a quality all its own when disparities reached these levels. The P-38's fighter-bomber operations over Italy and later France represented more than tactical innovation. They demonstrated the obsolescence of specialized attack aircraft doctrine that had dominated military aviation thinking since the First World War. The concept that certain aircraft should be optimized for bombing while others provided fighter escort was being replaced by a new paradigm: multi-role aircraft that could perform both missions simultaneously. This shift had profound implications for post-war air power development. The United States emerged from World War II committed to multi-role capability as a design principle. The jet fighters developed in the late 1940s, the Lockheed P-80 Shooting Star, the Republic F-84 Thunderjet, the North American F-86 Sabre, were all designed from inception to carry bombs and rockets while maintaining air-to-air capability. The concept reached full maturity with aircraft like the Ford Phantom, developed in the 1950s, which served simultaneously as an interceptor, air superiority fighter, fighter bomber, and reconnaissance platform. Modern multi-role fighters, like the F-15 and F-16, trace their doctrinal lineage directly to lessons learned with the P-38 over Sicily in 1943. The Germans, by contrast, never fully adapted their doctrine during the war. The Luftwaffe continued producing specialized aircraft throughout 1944 and into 1945, even as their operational circumstances made such specialization increasingly untenable. The Me-262 jet fighter, potentially the most advanced aircraft of the war, entered service in two versions: a pure fighter variant and a dedicated fighter-bomber variant. This represented the persistence of specialized thinking, even when German forces desperately needed aircraft that could perform multiple roles. Hitler's insistence that the Me-262 be employed primarily as a bomber, overruling Luftwaffe preferences for fighter operations, reflected strategic confusion born from institutional habits that no longer matched tactical reality. The jet's speed gave it immunity from Allied piston-engine fighters, but German production could only deliver several hundred aircraft before war's end. Had these few aircraft been designed for true multi-role capability, engaging Allied fighters and bombing ground targets in the same mission, their impact might have been greater. Instead, they operated in specialized roles, their numbers too few to matter strategically. The institutional thinking that produced the Stuka doctrine in the 1930s still shaped German decisions in 1945, even as that doctrine lay in ruins across the battlefields of Europe. British air forces followed a trajectory between American and German approaches. The Royal Air Force maintained specialized aircraft types longer than the Americans. The Hawker Typhoon and Tempest served primarily as ground attack aircraft, while Spitfires focused on air superiority, but increasingly employed aircraft in mixed roles as operational demands required. The jet age brought British doctrine closer to American multi-role thinking, though resource constraints limited the UK's ability to develop and field multiple specialized types. Soviet air forces, operating on the Eastern Front where tactical circumstances differed significantly from Western Europe, developed their own solutions. The Ilyushin Il-2 Sturmovik ground attack aircraft served roles similar to the Stuka, but with heavier armor and armament that gave it better survivability. Soviet fighters like the Yakovlev Yak-9 carried bombs when required, but were optimized for air combat. The Soviet approach emphasized simplicity and mass production over technological sophistication, a doctrine that served them effectively given their strategic circumstances and industrial capabilities. The P-38's influence extended beyond doctrine into industrial practice. American aircraft manufacturers learned that flexible production lines capable of building aircraft in multiple configurations, with varying equipment fits, were more valuable than specialized facilities optimized for single variants. Lockheed's Burbank facility produced P-38s configured as fighters, fighter bombers, photo reconnaissance aircraft, and even night fighters, all on the same assembly lines with modular installation of mission-specific equipment. This manufacturing flexibility became standard practice in American aerospace industry, influencing post-war production methods for both military and civilian aircraft. The maintenance and logistics lessons were equally significant. Ground crews maintaining P-38s learned to service aircraft that might be configured differently from one mission to the next. Supply chains had to stock components for multiple mission profiles. Training programs taught pilots to operate the aircraft in varied roles. These organizational adaptations created institutional knowledge about supporting multi-role aircraft that paid dividends throughout the Cold War and into the modern era. The American military's ability to deploy and sustain complex weapon systems in austere environments owes much to lessons learned supporting flexible aircraft like the P-38 during World War II. Return now to Hauptmann Klaus Weber, circling over the burning wreckage of that German convoy near Randazzo in August 1943. He had watched 6 American aircraft deliver more destructive power than a dozen Stukas, then disappear before interception was possible. He had filed his report, documented what he observed, and continued flying his patrols over Sicily until the island fell to Allied forces. Weber survived the war. He was captured in April 1945, after his airfield was overrun by advancing time, American ground forces. In post-war interviews, he spoke about his experiences with the analytical detachment of a professional military officer assessing tactical problems. What struck interrogators was not his bitterness, though he had reason for that, but his intellectual honesty about German failures. Weber acknowledged that Luftwaffe intelligence had accurately reported American capabilities. The information existed. What failed was the institutional ability to act on that information in ways that challenged established doctrine. The specialized aircraft concept had worked brilliantly in the early war years against unprepared opponents. It had become orthodoxy, defended by organizational inertia and resource constraints that made radical changes impossible, even when their necessity was obvious. Weber never flew a mission in a Stuka, but he understood what that aircraft represented. German engineering excellence applied to a specific tactical problem. The Ju-87 was not a failed design. It was a superbly successful design for circumstances that no longer existed by 1943. The tragedy, and Weber used that word, was not that Germany built specialized aircraft, but that the military system could not adapt when specialization became liability. The Luftwaffe knew it needed multi-role capability. Engineers could have designed such aircraft. Industry could have produced them, though in smaller numbers than specialized types. What was missing was the institutional will to make hard choices when those choices invalidated years of doctrinal development and operational practice. The American aircraft industry made different choices, enabled by different circumstances. The United States had industrial capacity that permitted experimentation and the production of multiple aircraft types simultaneously. American commanders had the luxury of testing new concepts without risking immediate strategic catastrophe if experiments failed. These advantages were not merely material. They reflected a military culture more comfortable with flexibility and adaptation than with doctrinal purity. The P-38 became a fighter bomber not because Lockheed or the Army Air Forces planned it that way, but because commanders in combat theaters recognized opportunities and exploited them. The system allowed and encouraged this kind of innovation. The story of the P-38's 4,000-pound bomb load is not primarily about engineering or tactics. It is about how military organizations learn, adapt, or fail to adapt when battlefield realities contradict established beliefs. The Germans confronting P-38 fighter bombers over Italy faced evidence that demanded doctrinal revision. They documented this evidence. They understood its implications. But institutional structures built around specialized aircraft doctrine could not transform themselves quickly enough to matter. By the time German forces recognized what needed to change, they lacked the resources to implement those changes on scales that would affect strategic outcomes. The Luftwaffe pilot watching American Lightnings bomb his ground forces with impunity was not witnessing superior American bravery or tactical skill, though both existed. He was witnessing the consequences of industrial capacity married to doctrinal flexibility. The American system could produce thousands of multi-role aircraft and employ them in ways that exploited their capabilities fully. The German system, constrained by resources and bound by doctrine, could only respond tactically to strategic problems. No amount of courage or skill could overcome that fundamental mismatch. When Weber watched those bombs fall from a twin-boomed fighter on that August morning, he was witnessing more than a tactical innovation. He was witnessing the future of air warfare, a future where flexibility and multi-role capability would replace specialization as the dominant design philosophy. The Stuka 2,000-pound bomb load had been adequate for the war Germany planned to fight. The P-38's 4,000-pound load was adequate for the war America was prepared to wage. The difference between those numbers measured more than payload capacity. It measured the distance between two different visions of warfare, two different industrial philosophies, and ultimately, two different outcomes. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.